Hello everyone and welcome back. Now we have explained why we have the tokens and what do we need for them. Let's continue with our lexing. I will have a lex function which we will give our arguments, and of course we will give an address to our tokens so we can use them. Let's go to our header. I will declare our lexer here. It will be an integer and it will have constant char pointer to string t vector pointer to output tokens, and this will return 0 on success. Non-zero will be error. It can be set, then it will set a parse error. Okay, now let's create another C file called lexer.c, and we can start by including my BC header, and we will also be needing C type.h, which you will see. And let's briefly explain our lexer, which I showed in the paper, but let's show in the code again. It will have this string and it will give us tokens. Sounds simple. Tasks or responsibilities of this lexer will be parsing integers in the base of 10. That's important. It will recognize operators, like we mentioned before, plus, minus, multiplication, division, modulus, and parentheses. It will be skipping spaces, very important. It will detect unary, plus or minus at the beginning, after, let me type them. Changes, beginning of input, after the left parenthesis, and after another operator. And then we will have the unary signs. Let me type them again, just in case. We will have the backquote, and we will have the backquote for unary plus, and we will have the tilde for the unary minus, and we will have parse errors if something does not look right. And this is basically what our lexer will be doing. We already declared the function, so let me just copy this. And here, in parentheses, we will have a size t of I equals 0 for the beginning. And yeah, we need to add some libraries, headers. Let's do that. It will be, we can put it in the header actually. std int. I think it was think if you also put the standard definition header, yes, that's enough. We have size ti. We will have a big while loop that we are iterating, so that's why we are doing it. And I will say expect unary equals 1. This will be we begin in a context that will allow unary, expect unary, I don't know how to say it, probably. But yeah, basically we will have a big while loop. While s of I, our string of I exists, we will do some checks. For example, we need to check for spaces. Then we need to check if we have digits. And we will check if you don't have digits, do we have like operator, minus and plus, or like other possible operators, multiplication, division, or modulus. And we will be also checking for the parentheses, right and left and right parentheses. And if nothing else is working, we will be saying unknown character, and it will be just parse error. So to start with the digits, I will have a small helper function. Actually, no, let's just use some standard functions. There's a function called isSpace, which will have an unsigned char s of I. It will return 1 if it's a space. If there's a space, we will increment the I value and continue with our array of the string. This is our first check. The second check, if it is a digit, if is the digit. Again, I am giving an unsigned character. Again, s of I. And if it's a digit, we will be parsing a positive integer literal. And if it's an unary, sign, it will be handled as an operator token. So we will have a long v, which will be 0 by default, and while that our digit of unsigned char for s of I, we will have a 10 base 10 integer. So we will be saying v equals v times 10 plus the s of I minus 0. This will help us get the integer out of the char. And then we will increment the I. I hope this makes sense because it's kind of simple actually, but we are just getting 10 base of integer. And then we will need to push the integer to our token. So let's have a helper function. I will call it static int push int, which will have t vector out and long v value. And we have the t token t token. You can just go check the t token, what it expects, type eval op flag association. What's the problem here? Okay, I will check again another time. So for token t, we will be saying, okay, our type of the token is token integer. Our eval will be integer value will be v. T dot operator will be 0. T dot check will be 0. T dot association will be left association, and then we will be returning our vector. For that, we will need a vector pusher. Let me just type it for now. We will create a function called vector push, which will give the pushed output of a vector token. I am coming back to dynamic array. This is a void function. Let's fix it. Okay, so next I am creating an integer vector push function, which we just said. It will have a tvec of vector of v and constant void string pointer to the element which we gave in the function. Let's have a quick error handling. If the vector size equals to vector capacity and okay, let's just keep it for now because we will add another statement. If that's the case, we will be returning -1. I will come back to this later. And we will be copying the vector size of pointer v data plus v size times v elements. So we will give the elements and we will also give the v elements. And this, yeah, I think this will copy correctly the size of the elements plus elements and elements. I hope that's correct. And then we will increment the size of the vector. And then if it's all good, we will return 0. Okay, here we have other helper functions, but I will come back to that in a moment. So let's create another helper function. Again, it's a static integer, which will returning 0 for success. It will be our vector grower function. and it will have the t vector type pointed to the vector. So first let's have a n cap size t value. Okay, first we will check if our vector has a capacity already. If that's the case, the new capacity will be vector's current capacity times 2, else the n capacity will be 8. If there's no capacity, if it's 0, at allocated capacity will be 8. Now we have a void p, and we will use malloc to allocate some memory, and n capacity times vector of element. We are allocating some memory to our p pointer, and let's have a quick check statement. If it doesn't exist, we will return -1 for error, and if the data exists in our vector, we will be copying void mem copy. We will give it the p. We will give our data. We will give our vector size times vector element, and then we can free the data that we used, and then the vector data will be the p we allocated, vector capacity will be the new capacity, and then we can return 0 successfully. So after checking the if size the same as the capacity, we can also check for if our vector can grow, and we will give it our vector. If it can grow and not equals 0, 0 will mean success. If it's not equal to 0, like -1, then it will return -1, showing us an error. So now we have our vector push and vector growth. Let's copy and paste these in our header. So we have vector initializer, vector freer, we have vector growth. Actually, we don't need vector growth. This will be only used in this the helper. So we need the vector push actually. And yes, vector initializer, free, push, and we are working our dynamic array. We will have a couple more to check the vectors in the position or pop them or clear them, whatever. So this is okay for now. So going back to our lexer, we found the digits in our string that came from the user. We are parsing it, we are lexing it. And if it's an integer, we will push the integer, and we have the vector pusher. And this will push the element to our vector with help of the grower, which will make the vector, which will grow the vector, and then we can push it successfully. And the lexer, checking if it is digit. And if push int. Okay, let's not push the if first. Let's say, okay, push int. It will be pushing our output token using push int function. Of course, we will also give our vector, and this will return 0 if it's successful. So let's just put it in parentheses, say if this is not equal 0, it means there's an error. Then we will call our set parse, and also we will be returning -1. So this way I'm trying to keep this code clean. And also after this, expect unary will be 0, because after a number, following, it means this is an integer number. After a number following minus or plus means it's a binary. So we don't need to expect unary after that point. We have already checked for our integers, digits. So let's now check for the plus and minus. So I will have an else if saying s of I, our string, equals plus, or s of I equals minus, which here, and if that's the case, we will need another helper function that will be called static integer push operator, because we already have one for pushing the integer, so we need another one for pushing the operator. Again, this is getting t vector pointer of out, just like our integer pusher. This time it will also need to have the char operator, and we will be checking if it is on a okay, so t token t, initialize a token, and say, okay, the type of this token will be token of operator. The value of I is 0, and t dot association will be sock left, and we will be checking if unary or not. Okay, if it's unary or not. If that's the case, we will map to a syntactic unary op symbols with highest precedence, and it will be right associated. Let's check what is our operator is. If it is minus sign, I don't need that. We will say t op equals unary minus. If, let's say else, if operator equals plus, t dot operator will be unary backward unary plus, and else we will have error set parse. If it's not one of them, it means there's an error, and then we can just return -1. And t dot precedence will be 3. I explained it previously why we are putting 3, and association will be assoc right. Else, if it's not unary, t dot operator will be the operator basically, and if the operator equals to asterisk multiplication, or operator equals to division, or operator equals to modulus, we will have the precedence of 2. T dot association will be left associated, and if that's not the case, we will be saying t dot preg equals 1. It means this will mean like plus or minus, that's why precedence is 1. And t dot assoc will be assoc left associated. And that's, if that's the case, we will again push our vector, and it will be the out and address to the token we created. I think this should be correct. Again, we will do some error checking later, but I think it looks fine. So let's continue with our else if. So we are checking for operators here. Wait for the comment. If that's the case, we will say push operator, and we will give it output tokens. We will give our I of s, and we will be saying if you should be expecting unary or not. And of course, like the other ones, this will return 0 or not. So let's just put it in a if statement and say if this is not 0, it means it has failed to push the operator. We will again set parse error, and we can return -1. I am doing the error handling the way as long as we go, so it will be clear at the end. And in that case, we can increment the I, and after any operator, the next could be unary. So I will say expect unary equals 1, because you never know. And we will continue with the case if we have other operators. So I will be saying if our strength in the index of I equals to asterisk, or s of I equals division, or s of I equals modulus, that case we will check if these are unary. These cannot be unary. So first we will check this quickly, and we will see if expect unary is on. If it is 1, we will basically just say, okay, give me parse error, and of course return -1 showing the error. If that's not the case, we will just continue with pushing operator, same as this one. I'm just putting it already in the if statement. Again, we will say push operator. We will give it output tokens, and then we will give the s of I, of course. For expect unary, we will just give 0 because it should be 0 if it's if one of these operators. We don't expect unary, we just want it for minus and plus. And if this is again, if this equals to 0, it means there's an error, and we will say set parse error again plus return -1. But if we don't return it, we will increment our array, and we will say, okay, after this, there's a possibility we will have a unary. So this, we have checking spaces, digits, plus minus with unary, presence of second presence of operators, this one. This can be 1 or so this can be return 1 or 3 depending on the precedence, if it's unary or binary. And another else if for checking the parentheses. That's what we have left. If s of I is the left parenthesis, that means we are opening a parenthesis, and then we will need another helper to push parentheses. And let's create after this one. Again, static integer, push parentheses, t vector pointer to the out, just like others, and integer left. Again, t token t dot type will be checking if it is left. That's why we give it the left, because we have left or right. If that's the left, we will say, okay, this is token left parenthesis. If it's not left, okay, this is token right parenthesis. T dot y is 0, t dot op is 0, t dot precedence is also 0, t dot association will be the left associated, and then we will be returning a pushed vector push, give it our vector and output and our address to the vector. I just want to make them look a little bit better. Yeah, just a tiny bit better. And so now we can push our operators. Let's come back to the lexer and say, okay, we have our left parenthesis, and we will say push parenthesis, and again output tokens, and this time we will give 0 because this is the this is the left one, so we will give it 1. If this is left, yes, then left parenthesis 2. We give it 1 because this is left parenthesis. And let's put this also in a if statement so we can do error handling. If this doesn't return 0, again we are saying set parse error and return -1. At this point we are just kind of repeating what we do again and again. Okay, so this time after the parentheses we can expect unary, of course. After parentheses there can be possibly an unary, and if it is not the left parenthesis, we only have one more option left, which will mean this is the actually else if s of I equals right parentheses, then we will have the same of this. I'm just gonna copy and paste. I'm lazy, sorry. But this time this will be 0 because this is the right one. And it's exactly the same as the left one. And for the last possibility, we have an error. So again, I am saying, okay, add error set parse and return -1. And that's the final possible case. So if we come to this point successfully, then we can return 0, meaning success. And I think this is concluding our lecture. Off the camera, I created a quick print statement to test our lecture. And let's just say make mem copy. I'm missing, yeah, let's include string h. Again, let's say make main lexer. Did I put this in Makefile? No, let's do that. Source lexer.c. Again, okay, this it compiled successfully. Let's call my.bc and give it 1 plus 1, 2, 3, 43. Okay, we have parse error. Let's do it again, but put in the parentheses because, yeah. Okay, now it is lexing our argument. We have integer 1, that's correct. Operator plus, that's correct. We have integer 1, 2, 3, that's correct. Operator minus, that's correct. And integer 43. Let's give it a little more complex thing. Actually, I will just copy the existing equation I have. Minus 4 plus minus fix. Let's see how it works. We will have operator tilde, which is for unary minus, which has precedence of 3, and right associated correct, left parenthesis correct, operator another unary minus. So we have tilde again as the precedence of 3, association of right, that looks correct. Left parenthesis, operator unary minus, that's correct. Integer of 4, that's correct. We have first right parenthesis, that's correct. We have plus, operator of unary plus, which is backward. And again, we have another. I am not sure if this is supposed to be a plus or this. We will come back to that again, but other than that, this looks correct. Because of this also looks correct. And that also looks correct. Yeah, just a tiny fix. I just noticed I made a mistake. After the right parenthesis, we are not expecting unary. We are going to change to 0. I will say make again. And when I run the same equation, this time we have plus, and we have a working lexer, and all looks good. So thank you for watching, and see you in the next one.